Hello class, today we'll be doing two column proofs. Alright, so first thing we have to do is number our letters. So we have to prove that triangle BCD is the same thing as triangle ECD. They're equivalent. So we're going to make B and E the same one. So they're both 1. And then C and C will be the same thing and they will both be 2. And then D and D will be the same thing and they will both be 3. So that means B will be 1. E will be 1, C will be 2 for E, and C will be 2 for B. And then D will be 3 for each of them. So it's 1, 2, 3, 1, 2, 3. They're equivalent. And do you see these little corners, the squares in the bottom? That means that they're right triangles. That also happens to be one of our givens. That triangle BCD is the same, and triangle ECD are right triangles. So let's write that down. And then that would be a given, and that's what we write in this box. We also have another given, and that's that line BC is equivalent to line ED. So that since these are already marked on our chart, we know that they are equivalent, which means you also have to write them there. So line BC is equivalent to line ED, and that is another given. And then we have to write our proof in the bottom, like always, You always write your proof in the bottom. But how do we solve this? There's side angle side, there's angle side angle, but there's no ass. There's also hypotenuse leg, which is what this is. Because it has a hypotenuse and has a leg. Hypotenuse leg. Basically, anytime you see these right triangles in it, it's safe to say that's hypotenuse leg, especially if they're connected in this general shape. Okay. Proof hypotenuse leg. And then we also need to know if something else is equivalent. And because these two are equivalent and we have no markings here, there's only one place we have a marking left, and that's in the middle. And that means that this DC is equal to CD. So let's write that. Line DC is equal to line CD. And then that would be the reflexive property, because they share the same line. All right, whole class is going to take 5 to make sure everybody gets the notes properly, and I am going to set up the next 2 column proof. All right, welcome back, class. I hope everybody had a very nice short little break. I hope you guys drank water. I hope everything was great. But so now we need to solve our second 2 column proof. What do we do first?
We number the letters.
Number the letters. So the proof is LMN equals ONM. So L would get a 1, O would get a 1, M would get a 2, N would get a 2, N would get a 3, M would get a 3. So now we number them here. There we go. We are a fully numbered diagram. So first of all, we need to write our givens. Our first given being LM equals ON. And we write given because it's given. Our second one is MO equals NL. And that is yet another given. I'd like you to notice something. So on here, LM and NO. LM, 1 hash mark, and it's on this side. On the exact opposite side of the triangle, it is NO. So that is flipped over, and they're equivalent sides. You can tell because they have the same number of dash marks on the side. And then for the second one, MO and NL, MO, 2 dash marks, NL. two dash marks as well. So they're equivalent. And then we have one more given, and that's that MN bisects triangle LMN and triangle ONM, which means it basically just cuts them in half, being it's in the very middle of it. It's the bisector. It's in the middle. So then we write that. And then we always have to write the proof on the bottom one. And that's the proof. And because this is a shared side, what's that going to be? You got it right, reflexive property. Which would mean MN equals NM. Now, do you see any angle markers here? No, you don't, and I'm going to tell you why. Because it's side, side, side. That's the way you get the proof. Side 1, side 2, side 3. That's two column proofs. Thank you for coming to my TED Talk.